Okay, so to do part A in your notes, what you want to do is take your calculator and go ahead and hit second and then the vars button. So here's what that's going to look like. Second, vars, and then go to where it says normal CDF. And then you're going to put your lower bound, which in this case is -2, and then comma, your upper bound, and then your mean, and then a comma, and then your standard deviation, and then close your parentheses and hit enter, and it will give you your answer. So again, this is the format of what you're putting in your calculator. So normal CDF, your lower boundary, which is that, your upper boundary, which is 1, your mean, and your standard deviation, in that order. And then we end up with an answer. If we go with 3 significant figures, it would be 0.819. For part B here, as you can see, we don't have a lower boundary here. We just have the probability that z is going to be less than 1. So when you use the normal CDF function in your calculator, it calculates the probability that you are going to end up with a value between 2 boundaries. So if we want something less than 1 and we're working with the standard normal curve, we just have to pick a really negative value to plug in for our lower boundary. So I chose the lower boundary of -90, which means when I put this in my calculator, I'm going to do second, vars, and then normal CDF, and I'm going to do -90, 1, 0, 1, and I am going to end up with this. So that makes my probability, if I go accurate to 3 significant figures, that would be 0.841. Okay, so for part C, it's very similar to part B, except we're going the complete opposite way. So if I want the probability that z is going to be greater than -1.5, I just need to pick a really high upper boundary here. So I chose 90. And so you're going to put this in your calculator as normal CDF, and you're going to do -1.5, and then 90, and then 0, and then 1, and then enter. And that, of course, accurate to 3 significant figures would be 0.933. Okay, for part D, anytime you're looking for the probability that your random variable is going to be less than or greater than your mean, your answer is going to be 50%, because you have to remember that your mean is splitting your data right in half, which means that the probability that you're going to have a value that is less than your mean is going to be 50%. The probability that you're going to get a value that is greater than your mean is 50%. So I'm going to skip to part E. Okay, so if you have the requirement that the absolute value of z is greater than 0.8, then you have one of 2 things happening. Either your z value is greater than a positive 0.8, or it is less than -0.8. And as a result, since we have 2 different ways to achieve this, we are going to have to add a couple of probabilities here. So we're going to do the probability that you end up with something that is greater than 0.8, plus the probability that you end up with something that is less than -0.8. So in your calculator, you are going to do your second, vars, normal CDF, and then 0.8, 90, 0, 1, and then plus your second, vars, normal CDF, -90, -0.8, 0, and 1. And there is your answer.